Okay, so lesson 7, algebraic expressions, commutative and associative properties. Say hello to Miss Tucker. She's going to help me out here. This is Miss Tucker if you don't know her. She's in the pre-algebra classes with me. She's also in your ELA classes. Okay, so it says Susie draws the following picture to represent the sum of 3 plus 4. So let's turn this sideways. So I'm going to be Susie. Miss Tucker's going to be Mr. H. So it's laying here. I've got 1, 2, 3 blocks, 1, 2, 3, 4 with these lines. Why, when Ben looks at this picture from the opposite side, he says, you drew 4 plus 3. Well, let's think about how we read. Looking at this, we read from left to right. But if I flipped you upside down, your left to right, oh, well, that didn't do a darn thing. I actually don't know. Your left to right should be this way to this way. I don't know if it did when I flipped it upside down. I don't know, because I'm not flipped there. No, I'm just making you dizzy. How's that going? Is that good? Okay. So when we're looking at it from opposite sides, it's going to look differently for us. So there's two different ways to look at this. 3 plus 4, or if you're on the opposite side of the table, reading left to right, 4 plus 3. That's going to be important as part of the commutative property. You're good. That's all I needed. Cool. Okay. So Susie adds a little bit more because Susie's an overachiever. Remember, I'm Susie. So the picture now represents 3 plus 4 plus 2. When you have multiple expressions like this.
Lengths to the office, please. Chase, lengths to the office, please.
So when we have 3 plus 4 plus 2, you need to show what you want to do first. In this case, we have 3 plus 4. This is what Susie, me, wanted to add first. 3 plus 4 is what gives us 7 plus the extra 2, which is 9. And we can see that 1, 2, 3, 4, 5, 6, 7, 8, 9. But again, Ben's on the other side of the table. So how would Ben see this? Well, if we're working this from left to right, Ben would see this as, hey, I see 2 plus 4 plus the 3. What we've just done here is the commutative property, not commutative, commutative. Okay, the commutative property states it does not matter the order in which we add something for us to get the same answer. Adding will stay the same. So 2 plus 4 is still 6. 6 plus 3 is 9, because order of operations tell me to do parentheses first. We still end up with 9. It's just a different order in which we've put the parentheses. So what other properties are we going to learn? Because that's the commutative property of addition. Well, wait a second, Mr. H. Susie draws another set of squares. And she has 3 times 4, and Ben moves to the end of the table and says, nope, looks like it's 4 by 3. Ben seems like a pain in the rear end. I'm just saying, Ben just kind of wants to say, hey, Susie, you're wrong. Ben's a jerk, by the way. What picture might Susie have drawn? Why? Well, let's see. Susie's going to have drawn, as I'm about to cough up a lung, Susie's going to have drawn something that looks like this. 1, 2, 3, 1, 2, 3, 4. Okay. Is that right? Did I do it right? I did. Yay! So Susie's looking here at this. She's looking this way. Ben's looking this way. Because again, Ben's just trying to prove Susie wrong. Now, do we need the pictorial representation? Not really. Do I need to draw this picture? No. But I want you to understand why it does not matter the grouping. So not only did they do the commutative property here, they switched a lot of things. So 3 times 4 times 5, you do the parentheses first. This is 12 times 5, which is 60. Over here, even if we didn't switch them, because I don't want to switch this. This is just the way that they did it. I still want 3 times 4 times 5. They moved the parentheses to this. Okay, that's really what they did. 4 times 5 tells me to go first, which is 20, times 3, which is still 60. So we have two properties now. We have the commutative property of addition and the commutative property of multiplication, which says it does not matter the order in which we multiply. It does not matter. You've heard me talk about this in 7th grade math, the commutative property, quite a bit. And if you're like, no, you didn't, Mr. H, well, you're liars. Yes, I did. And if I didn't, I'll show you videos where I did talk about it because I've got hundreds of them. So why is this important? Well, there are 4 properties that truly matter. Commutative property of addition means it does not matter the order in which we add. The associative property says it does not matter the order in which we group the numbers. Okay, wait a minute, Mr. H. You said this was the commutative property. I showed you the associative property. I got ahead of myself. This is the commutative property because it switches things. I showed you the associative property. My bad. I'm not going to lie. Got a little ahead of myself. Got excited. So the associative property says, hey, as long as they're all addition, it doesn't matter which way I group them. Commutative property, again, I can flip the order of anything. So if I wanted to write this property as the commutative, I could say, and let's just use this right here. If I wanted this as the commutative, I could say B plus A plus C. I didn't change the order in which I moved the parenthesis, I just changed the order in which I added them. That's commutative, okay? That's where I made a mistake. So the associative property is changing the parentheses, commutative property is changing the order in which they're written. So viewing this diagram, 3 plus 4 plus 2 equals 2 plus 4 plus 3. So what actually happened? So not only did we swip these, but we also swapped everything. So this is hugely the commutative property. So is it true for all real numbers at x, y, and z that x plus y plus z should equal z plus y plus x? Yes, that's absolutely true. Okay, so now we've got, go ahead, what? Yeah, it's right there on this desk. Okay, so now we get into the fun stuff. Draw a flow diagram and use it to prove that x times y times z is the same as z times y times x. Okay, so flow diagram. This is going to change things a little bit. So we start with x times y times z. So the next thing that we're going to do is I'm going to draw an arrow with a circle. And in that circle, I'm going to put what the property is. Well, first I'm going to move the parentheses. So now I have x times y times z, because we want the y and z together. So what property did we use? We used the associative property of multiplication. Okay, well now what do I need to do? Well, now I need to flip the yz and the x. Okay, because we want the x at the end. So what property did I use here? Well, that's the commutative property of multiplication. Why? Because we're still multiplying. Last but not least, now I've got, because we wanted zy first, zy times x. So now we flip the y and the z. That's the commutative property again of multiplication. So now I've used the flow chart, starting the associative property, the commutative property, the commutative property. These are going to be on your test. I'm telling you right now that you will see a flow chart like this on your test, except it will have circles that you put stuff in, and it should be relatively easy. So now down here with exercise 7, it says, hey, use these abbreviations. I don't personally like using the x. Last year I've told you several times, hey, why don't we use the x? Because the x is a variable. Could you use the x? Absolutely. Do I want you to? No. But for this, because that's what it says, use it. So here we are. We are filling this in. So starting here, x plus 4 plus 5 times a plus 2x times y. So what's switched? X plus 4 has become 4 plus x. Well, what happens when those flip as addition? Oh, well, that's the commutative property of addition. Let's keep on going. So what's changed here? Oh, this started in parentheses. The 4 is not in parentheses anymore. Now x plus 5, oh, it doubled all this up. So the parentheses moved. So what happens when the parentheses move? Well, that's the associative property. But it moved on addition, so that's the associative property of addition. Let's keep on going. Oh man, 4 went to the end now. So 4 plus is now plus 4 at the end. So that's the commutative property of addition. Okay, back up here. 5a. 5 plus, 2 came out times xy. So they changed where the parentheses were. So that's the associative property of, well, what's happening here? Multiplication. Last but not least, 5. A. Y came first, 2x came second. So they flip-flopped them. Well, what property is that? That's the commutative, but because they're getting multiplied, it's not Mr. H's way, the engaged New York way, we should have this c times the x. Questions, concerns, problems, We good? I hope so. You will have questions like this on your test. Same idea, same idea. Okay. A numerical symbol is a symbol that represents a specific number. So numbers are numerical symbols, okay? A variable symbol is a symbol that is a placeholder for a number. It takes the place, it represents a number that is unknown. It can be a letter, it can be a figure, it can be anything. An algebraic expression has numerical symbol or a variable symbol, or it's able to be in an algebraic expression which has those properties with addition, subtraction, multiplication, and division. We talked about this a lot in 7th grade. Two algebraic expressions are equivalent. Equivalent means has the same value but looks different. 2 plus 4 is equivalent to 3 plus 3. They have the same value, but they look different. That is important. A numerical expression is an algebraic expression that contains only numerical symbols, which means it does not have any variables. So an order of operations problem, like 3 times the quantity of 7 plus 9 squared equal, or plus 7 minus 2 minus 4 to the 8th power, is a numerical expression. As soon as I throw in a variable, it's no longer a numerical expression. Equivalence, again, they have the same value, they look different. Commutative and associative properties. When we use the commutative property, when we use the algebraic, or when we use the associative property, they keep the expressions equivalent. They change the look of them, but they keep the values the same. Folks, I hope you've had a wonderful day and a wonderful lesson. I'll see you the next time you come in.